All right, introduction to inequalities, just the basics. So we're not going to solve them yet. We're just going to talk about what an inequality is. So an inequality is an equation. An equation is using an equal sign to show that both sides are equal. Well, an inequality shows that both sides may not be equal. So for instance, you may see greater than, or you may see greater than or equal to. Kind of a new symbol here. So this is something new. It's like the worst color I could have picked. Gray, black. Then we have less than. Then we have less than or equal to. Let's pick a better color. Okay. Less than or equal to. So these two, these two are probably new to you. So the greater than, less than shouldn't be equal to, or shouldn't be different, excuse me. Greater than or equal to, less than or equal to should be new. So you really want to pay attention to these two because these are new things for you. So these show that they may not be equal. So either side of the inequality may not be equal to one another. All right, use an inequality symbol to make each mathematical statement true. Okay, so on this one, we're just saying, well, on 4 and 9, 4 is less than 9. If we have 5/10 and 45/100, I would suggest you add a 0 to compare these. So then you realize, wait a minute, that one is greater. If you don't add the 0, a lot of people will think of that just as 5 and they'll get it wrong. We have -3 and -2. So remember, if 0 is here, we have -2, -3. So -3 is farther to the left, so it's going to be less than -2. And then on this last one, again, I recommend adding some zeros, lining up your decimals. I'm going to add this 0 because then it's real evident. Oh, wait a minute. That one is much more. So we would say 1 4/100 is less than 1 4/10 or 40/100. Okay, so those are using mathematical statements to make these true. These are inequality symbols. Use the variable as the starting point when reading an inequality statement. So for instance, I would start at the x and read the opposite direction, basically. So I would say x, oh, that's a horrible x, x is greater than or equal to 6. So notice I started with the x. X is greater than or equal to 6. So in this case, I'm starting here and I'm reading that way. A value can substitute to determine if the inequality is correct. So what we would do is we'd say, okay, x plus 6 is greater than 11. Well, what about if x is 5? So we're just going to plug that in. 5 plus 6 is greater than 11. Well, 5 plus 6, doesn't that equal 11? So that cannot be true. Be like, nope, that can't be true. 11 is not greater than 11. So we would say that inequality is not true. On the next one, 7x is less than 45. Well, if we take this 6 and we throw it in here, 7 times 6, we know that that equals 42. Is 42 less than 45? It sure is. We would say that is a true statement. So we just took that 6 and plugged it into the equation of the inequality and made sure that it was a true statement. Determine whether the given value makes a true statement. All right, so again, we're going to take that 11 and we're going to take it and we're going to put it over here. 11 plus 8 is greater than or equal to 19. So if we take 11 plus 8, we get 19. We say 19 is greater than or equal to 19. Well, it's not greater than, but since they put that equal to, we would say yes, that is a true statement. It is greater than or equal to 19. All right, we're going to try a different one. We have 12 is greater than f if f equals 3. So if we do 12 is greater than 3, would you consider that a true statement? Is 12 greater than 3? I certainly agree. So I would say yes, that is a true statement. Okay, we have c minus 12 is greater than 30. If we take that 13 from over here, 13 minus 12 is greater than 30. Well, 13 minus 12 is 1. Is 1 greater than 30? I would say, no. So that is not a true statement. No true statement for me. All right, we have 16 is less than b minus 8. So 16 is less than 22 minus 8. So we do 22 minus 8, and that's okay to write over here if you want. We're going to regroup, turn that into 12. 12 minus 8 is 4. So we get 14. So is 16 less than 14? I would say nope. I don't think so, because 16 is not less than 14. So that is not a true statement, or it is a false statement. All right, let's try another one. We have x divided by 12 is less than or equal to 3. Pay attention to how I'm reading these, so you get in the habit of figuring out what's less than and equal to, greater than and equal to, all that jazz. So I'm going to take this 48, I'm going to plug it in. 48 divided by 12 is less than or equal to 3. Well, 48 divided by 12 equals 4. Is 4 less than or equal to 3? Well, it's not less than 3, definitely not equal to 3. So I'm going to say nope. That is a big false statement. All right, let's try another. So I'm going to take this 15, I'm going to plug it in. So negative 10 plus 15, is that less than or equal to 20? So when we do negative 10 plus 15, we should get a positive 5. Is positive 5 less than or equal to 20? Well, it is definitely less than 20. So I would say, yep, this is a true statement. All right. How do you shade these in? So it says all the shaded numbers are true or part of the solution. So if it's greater than, we're going to have an open circle. That means, let's say this was the number 30. And I said x is greater than 30. Well, that means it cannot be 30. So we're going to do an open circle. And then we're going to color everything to the right. So that says it can't be 30, but it can be anything that's greater than 30. If we had greater than or equal to, so let's say we had, do a different color, x is greater than or equal to 30. So I'm going to say, okay, this is our 30. It can be equal to this time. Remember, see how it says greater than or equal to? So since it can be equal to, we're going to color in that dot. It's going to be a solid dot. That tells us it can be 30. It could also be everything to the right. That means it's greater than or equal to. So that equal to tells us to color in that dot. Now if it's less than, so let's do another one. So if we said x is less than 30, here's our 30. It cannot be 30 because it doesn't say equal to, but this time it's less than. So we're going to color everything to the left of it because we know less than is going to be to the left on the number line. If it's less than or equal to, x is less than or equal to 30, we're going to color in that dot because it could be equal, but it's also going to be everything to the left. So this is super important that you understand the difference. Anytime there's not an equal sign, we have to have this open zero, or open dot, excuse me. If it does have equal sign, we'll end up coloring those dots in. Super important when you're doing these. All right, so on this one, k is greater than 11. So I'm going to go to 11, and I'm going to have an open dot at 11, because it can't be 11. It doesn't say equal to, but k is greater than, so I'm going to color everything to the right. All right, we have f is less than or equal to 12. Notice I'm starting with the variable, and I'm reading this way. So f is less than or equal to 12. So since it's equal to, I'm going to color in 12, because it could be equal to 12, and then it's going to be less than. F is less than or equal to, so I'm going to color everything to the left. All right, D is less than 6. So since it's less than 6, it can't be 6. So I'm going to do an open dot, and I'm going to color everything to the left since it's less than 6. Okay, no equal sign here. All right, C is less than 25. So again, I'm going to have an open dot, and I'm going to color everything to the left. That means C could be anything that's less than 25. It could be 20, 15, 24.5, whatever, but it can't be 25, but it can be anything less than that. All right, B is greater than or equal to 0. So I'm going to color in, I'm going to have a solid dot, because it could be 0, because it's greater than or equal to, and then I'm going to color everything to the right. So it could be 1, 2, 3, 3.5, infinity to the right, whatever. But we know B is greater than or equal to 0. All right, X is greater than or equal to 4.5. So greater than or equal, so I'm going to go right here. Since it's equal, my dot's going to be colored in. Since it's greater than, I'm going to go to the right. Hopefully this is starting to make sense. Anytime we see that equal sign, we know we need to have that dot colored in. All right, using each verbal expression, write and graph an inequality. The McDonald family spend no more than $150 for groceries each week. So for me, they can spend $150, no more than. So they can spend $150, but they can't spend $150.01. So I would say they're going to spend no more, so they could spend, they have to be less than or equal to $150. Because they could spend $150, but they have to spend less than that. So to graph that, I have $150. It could be $150, so I'm going to do a colored in dot, but we also know it has to be less than that. So I'm going to go to the left. So these are tricky. You really have to think about what they're doing. Jared earns at least $10 when mowing lawns. Okay, so let's say, I don't know, Jared owns at least $10. So no, he's going to be greater than $10, but could he make $10? And you say at least 10? I think so. So it could be equal to 10. So he can do at least 10, but he could do 100. He could do 150. He could do 1,000. But it has to be greater than 10, but it could also be equal to, because it says at least 10. So the way I would graph that, I'm just going to put 10 here. I'm going to say it could be 10. He could do that. That's at least 10. But then he could also do a lot more than that. So I'm going to say I'm going to color everything to the right. So it's at least 10, it could be 10, and everything to the right. Jaslyn? That's a pretty name. Must score higher than a 92 on her science test to make an A. So she has to score higher than a 92. So her score has to be greater than a 92. That means it cannot be equal to, has to be higher than 92. So the way I would graph that, I would have 92, and it would be higher than, so I would have to open circle, but then color everything to the right. So that says it can't be 92, but it could be a 92.1, or it could be a 93, it could be a 94, it could be 100. I would maybe write this another way if we knew that it can't go over 100, but right now we don't know that, so we're just going to keep it just like this, keeping it simple. I won't go too much detail. All right, last one. I know this video has been long. I'm sorry. It takes Alex fewer than 15 minutes to walk to school. So Alex has to be fewer than 15 minutes. Could he be exactly 15? No, because it says fewer than. So the way I would graph this is I would have 15, and it has to be fewer than, so I'm going to have an open circle. It can't be 15, but it could be everything to the left. And again, we could write this a different way because we're probably not going to go below a 0. But for right now, like I said, we're just keeping it easy. So hopefully this makes sense on how the big thing we want to, the big thing we want you to know is how to graph these. A closed circle versus an open circle. We want you to know the difference between less than, greater than, less than and equal to, greater than and equal to. And then the other way is just to plug in numbers into an inequality to see if they're true. So those are kind of your big three that you're getting from this video. We will go into detail on how to solve inequalities in the next couple of days. All right, guys, thanks a lot.